Hello, my name is Ryan Minnema. I am a senior in the Industrial and Operations Engineering Department. I'm under Professor Amy Cohn, and the project title that I am working on this summer is Using Simulation to Optimize Hospital MRI Scheduling. An overview of what I've done this summer: I've researched types of scheduling and simulations that are used to imitate those schedules. I've studied and analyzed data to be used in the simulation. I created a Visual Basic program to generate an MRI schedule, and I plan to create a Visual Basic program to simulate the behavior of the above said schedule. So optimization, what is it? It is the use of mathematical models and algorithms to make the best possible decisions in a complex, important, quantitative situation. Who uses optimization, what fields? Military operations, logistics, manufacturing, transportation, healthcare, finance, and even sports scheduling. So the main optimization problem that I've dealt with this summer is, given a set of patients in need of an MRI scan, what is the best possible way to schedule them such that idle time of the MR machine is minimized, thus maximizing profit? Obviously, this is a simplified version of the real-world problem at hand. So what I did to start off my research, I looked at the actual hospital scheduling that was being done for MR machines at this time. And what I saw was the use of 50-minute blocks. No matter how long the scheduled procedure took, they only use 50-minute blocks, whether the average time for the scan took 30 minutes or whether it took 70 minutes. There are some rare cases where they would use 90-minute or 100-minute blocks. Another problem I saw was there were a lot of empty slots in the schedule. As you can see from the two diagrams, we have the scheduled version and then the actual of what happened during that day. The empty slots, a lot of that is attributed to emergency room patients being taken in and inpatient. Another thing I noticed were there was a lot of switching of scans between the MR machines. For example, if you look at MR machine 3, the first one, the neck angiogram, started off on machine 3 and the actual thing ended up on machine 4. They're not very sure of why this may occur, but that's an important note to take. The next thing I did was created a Visual Basic program which would generate a schedule. The first thing the program did was take in two different files, one to read in and one to write to. The one that it read in was an Excel file, and the one that I wrote to was an Access database. Next, the program would select the scheduling algorithm to be used. As of now, we have three different algorithms. The first one is 10-minute slots, offering every 10 minutes with patient refusal. The next is offering every hour, and the next is offering every 4 hours. So take this scenario. A person calls in, they need an MRI scan. The receptionist in the first algorithm will say, "We have an opening at 9, would you like it?" If they say no, you move on to 9:10. Same thing for offer every hour. However, it starts at 9, goes to 10, 11, etc. And for offering every 4 hours, it's 9, 1, 5, etc. The next, you have to select the percentile to be used, the 80th, 90th, or 95th. These percentiles correspond to the length of the procedure. For example, choosing the 80th percentile means that 80% of the scans will be less than this length for that procedure. Next is just selecting the percent of time a patient will say no to a time slot. And then finally, you select the time slots to reserve for potential ER patients. And all these buttons are just there for the user to set the different parameters without having to go into the code. Finally, we have the button to generate the schedule and the schedule being shown on your left, with the blue equaling ER patients, time slots reserved for them, and the red being just empty slots throughout the day. Here's just a picture of the data and what's being extracted from the Excel file. We have the procedure on the left, the frequencies, which corresponds to the percent of, or the odds of that procedure being called, and then the 80th, 90th, and 95th percentile lengths. So the next step in my research is to take the generated schedule and simulate what will happen. For example, the MR abdomen scan shown on the generated schedule is allotted 10 time slots, which is 100 minutes. But however, that could only take 80 minutes. The patient could arrive early or late. that could screw up the schedule. We want to see what's the optimal way to do it, whether it's with the 80th percentile length, 90th, or 95th. And that's where I plan to go next with this. Thank you for your time, and have a wonderful day.